call is now being recorded.
Hello. Hello.
Sir,
Hello, sir. Hello, sir.
Yeah, hello. Guys, you can hear me now? There was some mic issue earlier, eh? Is it, you can hear me clearly now?
Yes, sir.
Okay. One minute. All right. Guys, the others also, this will be a revision for you all for your IT as well. Okay, so just because we have been instructed to just uh, repeat the lecture for diplomats as well. Okay, so before we go for tomorrow's class, so that tomorrow I'm going to start off with
the mic is gone, sir.
okay, which is taking the open. Hello, is it now?
No,
Even now it's not clear.
no, sir.
Is there disturbance coming in the mic?
Yes, sir.
Oh, you
Yes,
can't hear me
sir.
clearly.
Sir, disturbance.
The disturbance, some static like.
Okay, 1 minute. I'll just check. Hold on 1 minute. Now is it clear?
Yes, sir.
Hello. Now is it clear, guys?
Yes, sir.
Yes, sir.
Okay, I just connected an external mic. All right. Okay, so we'll go for the presentation. Guys, this will be a revision for you all also. Okay, so I want everyone in it. And you all went through all the syllabus and the portion. All videos and all are up, right? Hello.
So, can you send
Yeah.
us those YouTube links as well?
Sure. I will send you all that as well. But the
Yes.
videos are not clear enough.
So, no, on the recording, it's really, how do I say, it's broken like.
I
It's
said.
a little
Okay.
blurred.
It's coming blurred.
Yeah,
Okay.
sir.
All right. I will. I'll send this thing to you all. Links to you all at least by Thursday. Okay. At least by Thursday, I will send you all the links. But whatever PPTs and all I have, I'll send you all by today. One of you all can just message me today. I'll send you all the PPTs and all today of logic gates and all that. Even that Excel sheet I have sent you all.
Sir,
Hello.
no.
Hello.
Yes, sir. No,
I
did
have not
not
sent
send.
the Excel
No,
sheet.
sir.
Okay. So one of you all can just remind me today. I'll send it to you all in the evening. Okay, by 6 o'clock or 7 o'clock. I'll send it to you on WhatsApp. I'll send it. Okay, so coming. You can see my screen, guys. Guys, can you see my screen?
So, wait, it's loading.
It's loading. Okay.
Yes, sir.
Okay. So coming back to the portion. Okay, our chapter goals, basic gates. Okay, so in this module one, okay, we will be basically learning all the basic gates, the behavior of each, okay. Then how these gates are implemented by using transistors. That means how we can use transistors and make all these basic logic gates. That is your and not. Okay. Then combine basic gates into circuits. Then we will learn on Boolean expressions, truth table, and logic diagrams. Okay. Then we'll even know how to use a half adder, full adder, multiplexer, SR latch, integrated circuits. Okay. This all comes under your gates field. So it comes under your digital electronics. Then gates, okay, and circuits, a device that performs a basic operation on electrical signals. Okay, electrical signals are what? Okay, 5 volt and 0 volt. Okay, so basically 1 and 0. So if you want basically, if you're getting for example, say if you're getting a yes and a yes, basically in the output you want a yes. But if there is one no, yes and no, you want basically at the output to be no. Then what gate you will use? You will use an AND gate. So you want some logical operation, okay, to be carried out. Okay, an intellectual operation. This is the very basic. Actually, if you go to see, it's the very basic of AI. Okay, using these gates. So it will give you an answer. So using your electrical signals at the input, you get a appropriate output. So for example, now we said yes and no. So instead of yes and no, I can take 0 and 1, which is binary. This is for diplomats, huh? So kindly hear properly. So you can take 0 and 1 as your input signal. Say for 0 and 1, you want 0. And for 1 and 1, okay, you want 1. So you will use what? A multiplication operator. Because we all know 1 into 0 is 0 and 1 into 1 is 1. Okay, but say you want 1 for 1 and 0 you want a 1, okay, and 1 and 1 also you want a 1. Then what you will use? Definitely you will use a OR gate, which is a additional. So it is using an additional operator. So we will go through that in a while. So this is basically the difference between gate, okay, and circuits. Circuits is what gates combine to perform more complicated tasks. So if you're basically using these gates to perform a more complicated task, that means there are more gate devices inside. It is basically known as a circuit. Okay, computers and electricity. So we are going to done with. We'll go through this Boolean expressions, logic diagrams, and truth tables. So we'll go directly now for gates. Now there are 6 types of gates. All right. Now this is what is important. First is your NOT gate. Second is your AND gate. Third is your OR gate. Fourth is your XOR gate. Fifth is your NAND gate. And sixth is your NOR gate. Now what you have to remember is that the NAND and NOR are basically what they are called. Guys, what is the NAND gate and NOR gate called?
Universal gates.
Very good. Thank you. So you'll remember. Good. So NAND and NOR are basically called as universal gates. Now, why they are called universal gates? Universal means it can be used to make any of these 4 gates apart. That means it can be used to make a NOT gate, AND gate, OR gate, or XOR gate. That's why NAND and NOR are considered as universal gates. Everyone clear? So NAND and NOR can be used to make any of these 4 gates. Okay, so that's the reason why it's known as a universal gate. But otherwise, how many gates are there? Totally 6 gates. All right. Now we'll go for the first gate. That is a NOT gate. Now a NOT gate accepts one input signal. Okay, it accepts one input signal and returns the opposite signal as the output. That means if I give a 0 here, okay, this is the Boolean expression. We'll go first for the Boolean expression. X equals to A dash. X equals to A dash. Now, what is A? A is the input signal, and this dash or this suffix which you can see on top, you can even put a line on top like this. Okay, you can even put a line on top like this. So this basically resembles the opposite signal. So if A is 0, then A bar, okay, is basically 1. A bar basically symbolizes the opposite. This symbolizes the inverse of A. X is the output. Okay. So the output equals to A bar. A bar means the opposite signal of A. So that means if in the input, see, you can see this NOT gate. This is your input A and this is your output X. So if your input is 0, if you're giving an input of 0, you're getting the output of what? 1. If you're giving an input of 1, you're getting an output of what? 0. And this is the symbol of it. So it is an inversion gate. Now what do you mean to say by 0 and 1? 0 and 1 are just levels. Okay? 0 and 1 are basically what? They are just levels. So if you're saying 0, it basically means what? 0 volt. If you say 0, it means what? 0 volt. And if you are saying 1, it means what? 5 volt. Okay, or 3 volt. So it is basically a voltage level. It could be 5 volt, it could be 3 volt, but higher than 0 volt. Okay, so the threshold for that is higher than 3 volt voltage. So this 1 is basically 5 volt and 0 is basically 0 volt. So when you say 0 and 1, this is how you categorize. Everyone clear with this? Diplomats, both of you are clear? This is for you all mostly. So you all have to be attentive. So you have A and you have X. So this is your NOT gate. This is what you all might have even learned in the previous class as well. I mean in your diploma time. Okay, we go to the next one. Okay, so now we have the AND gate. Everyone understood the NOT gate? Okay, so NOT gate, you will have only one input and one output. Now we'll go for the AND gate. Now AND gate, obviously you have to have more than one input. Otherwise it cannot be the AND gate. It cannot give you a operation, right? Now the operator used here is what? Now what do you mean to say by operator? Operator is the mathematical operator to give you the answer. So when you say AND gate, it is a multiplication operator. Okay, that means it multiplies both the input signals to give you an output. So the Boolean expression is x equals to a dot b, which basically represents a multiplication b. So a into b. So if your a is 0, so we'll take the first case. See, for this we had only two cases, 0 and 1. Okay, but the input was only 1. But here we have two inputs. Always remember when you're writing the truth table, first for b, meaning when you start from here, take 0, 1, 0, 1, and then multiples of 2, 0, 0, 1, 1. And here it will be again multiples of 2, so it will be 0, 0, 0, 0, 1, 1, 1, 1. So if there are three inputs, okay, so always go in this way to basically write your inputs. So you have A, B. So you have 0 here, you have 0 here. So 0 into 0 gives us what? According to the operator, 0. 0 into 1 gives us what? 0. 1 into 0 is what? 0. And 1 into 1 is what? 1. So this is the truth table, what you get when you use a AND gate. Everyone clear? So if you're getting 0, 0 here, you'll get a 0, 0, 1 here, you'll get 0, 1 into 0, you'll get 0, and 1 into 1, you'll get 1. So the operator used in AND gate is what? What is the mathematical operator? Multiplication. Okay? So the multiplication operator is used in AND gate. And AND gate is what? It is the total thing, which gives you, for both the input signals, it gives you the multiplication, it gives you the multiplication of both the inputs as your output. So this whole thing is called basically as a AND gate. And the operator uses the multiplication. Now we have the OR gate. Now in the OR gate, what we have? We have the addition operator. Now OR gate is basically using an addition operator. So you see the addition operator now. So x, according to the Boolean expression, a plus b. See, here there is a plus sign. That was just a dot. Okay, so you have to remember that as well. Okay, so it is a plus b. So now again we'll take for both the cases. Okay, a and b, and the output x. So 0 plus 0 gives us what? 0. 0 plus 1 gives us what? 1. 1 plus 0 gives us what? 1. And 1 plus 1 gives us what? 1. Now you will say here, sir, 1 plus 1 is 2, right? But we are basically thinking about the binary value. Okay. So 1 plus 1 gives us basically 1. Although the addition in the binary will give you in this way. It will give you 0 with a carry of 1. But we take it as 1 when it comes to an OR gate. So in an OR gate, when we give 1 and 1, we basically get 1. Everyone clear till here? So this is the values. Guys, till here any doubts?
No, sir.
Guys, till here? Okay. Vishwatej, Venkatesh, any doubts till here?
No.
No, sir.
Okay. So we'll go for the next one. Then we come for the XOR gate. Now, what it means? So you have an OR gate and you have an X. Now the X basically symbolizes XOR gate or XOR gate. Okay. Now, what you mean to say by a XOR gate? It's even represented as XOR gate as well. Okay, so if you get XOR gate, you have to understand it is the same as basically XOR gate. Okay, now what is a XOR gate? Now, when you say an XOR gate, your Boolean expression x equals to a, you can see the plus sign is there, but it is encircled. Now, when you have a plus sign and when it is encircled, it is basically known as an XOR gate. Now, what is the difference between a normal OR gate and an XOR gate? Now, here comes the major difference. So, again, we'll put our two inputs, A and B. So, our inputs are 0, 0, 0, 1, 1, 0, 1, 1. Now, 0 plus 0 gives us what? 0, right? It's a normal plus, right? Basically, it is a plus. 0 plus 0 gives us 0. 0 plus 1 gives us 1. 1 plus 0 gives us 1. But now, as I told you earlier, 1 plus 1 in an OR gate gives you what? 1. But actually, what is the value 1 plus 1? It is 0 with a carry of 1. So here the only difference is that 1 plus 1 will not give you 1, it will give you a 0. So as compared to the OR gate, the only difference is in this 1 here and in this 0 here. Here when you do 1 plus 1, it's basically a 1, and in an XOR gate means exclusive OR gate. It basically gives you a 0. So always remember, in an XOR gate, 1 plus 1 gives you a 0. So it will be what? 0, 1, 1, 0. Here it will be what? 0, 1, 1, 1. Everyone clear with this till here? What is an XOR gate?
Yes,
I'll
sir.
move. Okay, I'll move to the next one. So the difference between the OR gate and the XOR gate is that they differ in one input situation. That means this input situation. This one here and this one here. Okay, when both input signals are 1, the OR gate produces 1 and the XOR gate produces 0. This is basically what is the input situation. An XOR is also called as an exclusive OR, what I just told you. Okay. So, go to the next. Now we have the NAND gate. Now see, it is a combination of and you have N. N symbolizes what? NOR. N symbolizes what? NOT gate. NOT. So we have a NAND gate. So it is a combination of and a NOT gate. NOT, NOT gate, inverse gate. So you have a AND gate here. You have an AND gate here, and this dot, what you see, represents the NOT gate. That means the inverse gate. So we have A into B, and we have a bar. See, you can even put a line on top, a full line on top. That represents your bar. You can even write it in this way, but I feel if you put this line here on top, it is much better. Okay, so that represents your NAND gate. Now let's see how the NAND gate works. Okay, now the operation is the same. Okay, so you have A and B. So 0 into 0 gives us what? 0, according to a NAND gate, AND gate. Okay, 0 into 0 gives us 0. But here what we have an inversion. So that 0 basically becomes 1. Everyone clear with this?
Yes, sir.
Okay. Then the other one, 0 and 1. So 0 and 1 gives us what? 0. But the inversion becomes what? 1. Then 1 into 0 what gives us? 0. But here we have a NOT gate. So 0, inverse of 0 is what? 1. And then 1 into 1 gives us 1. But inverse of 1, when it goes to this NOT gate, it becomes what? 0. Everyone understood this? Till here? Vishwatej, Venkatesh.
Yes, sir.
Cool. Then we'll go for the next one. That is our NOR gate. Now, NOR gate is a combination of OR gate and a NOT gate. So this is our OR gate. This is our NOR gate. Okay. So we have what? X equals to A plus B, the whole bar. The whole bar on top. Okay, so it is A plus B and the inverse of this answer. So you can see the OR gate is here and then we have the NOT. So we'll try for the first input, 0, 0. So 0 plus 0 is what? 0. But this 0 is going to a NOT gate and becoming what? 1. Okay, the inverse of 0 is 1. So it's becoming 1. Then we take for the second case, 0 and 1. So this is 0 here, this is 1 here. 0 plus 1 is 1. But it is going to a NOT gate, so that 1 becomes 0. And again, similarly, 1 and 0 gives us 0. Okay, and 1 and 1 gives us 0. So 1 and 1, 1 plus 1 is 1, but 1 inverse gives us 0. So you have 1, 0, 0, 0. If you see your NOR gate and if you see your OR gate, just see the difference. For OR gate it is what? 0, 1, 1, 1. For NOR gate it is what? 1, 0, 0, 0. So it is just the inverse of it. In the same way, if you see the NAND gate, you have 1, 1, 1, 0. So for an AND gate, it is what? 0, 0, 0, 1. So let's see that AND gate part. You can see 0, 0, 0. So it is basically the inverse of your NAND gate is your NAND gate is your inverse of your AND gate, and your NOR gate is your inverse of your OR gate. All right. So review of gate processing. A NOT gate inverts the input signal. Inverts the input signal, that means if your input signal is 1, it becomes 0. If your input signal is 0, it becomes 1. An AND gate produces 1 if both the values are 1. See the statement. An AND gate produces 1 only if both the input values are 1. That means A and B should be 1. 1 and 1 for us to get a 1. Otherwise, it will be 0. An OR gate produces 0 if both the values are 0. Okay, that means it will only produce 0 when A and B is basically equal to 0. Otherwise, it will not produce. If any of the value, if either A is 1 or B is 1, then it will give us a value of 1. An XOR gate produces 0 if the input values are the same. That means if both the input values are the same. So if 0, 0, if A is 0 and B is 0, it will give us 0. And if A is 1 and B is 1, also it will give us 0. So if both the input values are same, then we will get a 0 as the output for the XOR gate. Then NAND gate produces 0 if both the inputs are 1. NAND gate produces a 0, okay, if both the inputs are 1. That means if you have 1 into 1, okay, which will give us 1, but the inverse of that will give us 0. Okay, so it produces 0 if both the inputs are 1. And a NOR gate produces 1 if both the inputs are 0. Okay, just the vice versa. So this is basically the review of the total gate what we have, gate signal processing what we have understood. Now gates with more inputs. Now see what we have seen is only A and B. but obviously they can be A, B, and C as well. So we'll see now with more than two inputs. So with more than two inputs, we get, see, as I told you how to write it, multiples of 2. 0, 1, 0, 1, 0, 1, 0, 1. Okay, then we have 0, 0, 1, 1. After that, multiples of 2. 1, 2, 1, 2. You can see this. So 0, 0, 0, 0, and then all of these become 1. In the same way, if you have another term here, then all of these will be 0 till here, and then again all equal 1s. You can see this. This is 4 zeros, 4 ones. 2 zeros, 2 ones. 1 0, 1 1. So it has to be basically in this form. So you have, it's like a sequence. Okay, it's like a sequence here. So you have A, B, and C. So you have a AND gate with three inputs. Three inputs A, B, and C. So you have 0, 0, 0 gives us what? 0 into 0 into 0 gives us what? 0. 0 into 0 into 1 gives us what? Again 0. So 0 into 1 is 0 again. 0 into 1 is 0. 0 into 0 is 0. So again 0. Then 0 into 1 gives us again 0. So in the same way, all these other terms also you will get 0. But for the last term, 1 into 1 gives us 1. Then again that 1 into 1 again gives us 1. So that's the reason why you got a 1. Till here everyone is clear?
Yes, sir.
Okay.
Yes, sir.
We'll go for the next one. Now we'll go for constructing gates. Now how these gates can be used? Obviously they have to use some mechanism how to make these gates. Otherwise how the gates will be used. So let's see how these gates. Okay, let's see how these gates basically can be made. Now the gates can be made using transistors. Using transistors. A transistor basically has no moving parts. As you all very well know, you all might have learned in the first year. The transistors are BJTs, FETs, and all these. These are basically switching devices. But what type of switching device? Electronic switching device. Just like how you have a normal switch. In the same way, you have a transistor. Only the difference is a switch is a mechanical device where you're using your finger to turn on or turn off a button. But here, you're using a signal to turn on or turn off any type of a device or a load. So a transistor is a semiconductor device. Okay. So let's understand the basic of a transistor. So a transistor consists of a source, base, and emitter. Now your base is basically that input signal which is given for it to turn on or turn off. That means if I give a signal here, you have a source and you have an emitter here. Okay? You have a source and you have an emitter here. So if I give a signal here, then your source and emitter will short and it will continue this circuit. But if I don't give a signal here, then the source and emitter will be open. That means current will not flow through this source and emitter. And if it doesn't flow, the circuit will be basically in an off stage. Everyone understood this? So if I give 0.7 volt here, then your source and emitter will turn on. If I don't give a voltage source here, your source and emitter will be open. Open meaning this will not be connected to this. Okay. If I give a voltage, your source and emitter will be shorted. When I say short, it will be basically there will be a continuity in the circuit. It will turn on the device. Venkatesh and Vishwatesh, all understood this?
Yes, sir.
Okay. So now constructing gates. The easiest gates to create, okay, are not NAND and NOR gates. Now we'll see how we can use transistors and create these gates. So now we'll take the first gate, that is the NOT gate. So you have your source and you have your emitter. Now just notice, your emitter is connected to your ground. Your emitter is connected to your ground. This is your V output. So here you will have your voltage signal. Okay, here you will have your LED. Okay, here you will have your LED. And this is connected to the source. Okay. Now, forget about this, whatever is inside. Okay. Just think like this. If this is open, okay, now it's a question to you. Vishwatej and Venkatesh. If this is basically open, that means this point is not connected to this point. Will this circuit glow? Will the LED glow?
Sir, no. Sir,
It will not glow
yeah.
because it is open, correct? Okay. But if I basically put a short here between this and this, then what will happen? The LED will glow, right?
Yes, sir.
Okay. So if you are providing an input signal at the base, what will happen here is that it will short. So if it is shorting these two terminals, here you'll have your voltage supply, here you'll have your LED, and this will maintain a continuity. Obviously, the negative of the supply is connected to the ground. So you will have a circuit continuity. So if you're providing a voltage signal here of zero point 0.7 volts, this circuit will continue. If you're not providing a signal, this circuit will not continue. So it will not work. So if I'm providing an input signal of 1, what I'm getting an output of 0. What I'm getting the output of 0. Okay. Why? Because everything is getting diverted towards the ground. Everything is getting diverted towards the ground. Okay. Now let's see for the NAND gate. Let's see for the NAND gate. Now if I'm having a voltage supply here of 5 volts, okay, we'll forget about the LED, we'll just take 5 volts. Same, the 5 volts it's basically shorting the 5 volts to ground. So you'll get the output as what? 0 volts. So now say we have V1 and V2. Okay, we have V1 and V2. And now this is a NAND gate. Now in the NAND gate, what is the value? 0 into 0 gives us 0, but inverse of that gives us 1, right? So we'll take 0 and 0 first. Again, you have your V output. Here in your V output, you're giving 5 volt. Okay. Here in your V output, okay, you're giving 5 volt. Okay. Now let's see what happens to the V output. When you're giving 0 and 0. When you're giving 0 and 0 here as V1, what is happening to these two? Shorting or opening? When you're given a input signal to this V1 here, what is happening to these two terminals?
Sir, it will be open, no?
If you're giving 5.7 volts here, what will happen to these two? Why it will open? It will short, no? So this terminal will be connected to this terminal. If you're giving 0 here, if no voltage is given here, then what will happen? It will remain in its default state, that is open. So if you're giving a voltage here, then only it will short, no? Otherwise it will remain open.
Yes.
Okay, just okay, forget about the LED and all. Just imagine there is a battery here. Okay, say there is a battery here. Okay, so you connected a 5 volt battery and the negative is connected to ground. Okay, so now say this is 0, this and this is shorted. This is 0 here also, A and B. This is basically A, this is B. Okay, so there's 0 here also. So what is happening?
0, 0 means it will be open, no?
Open. Okay, wait. Yeah, if it is 0, it is basically open. If there's 0 here also, it is basically open. Okay, so it will be an open circuit. If it is 1, then it is a short circuit. Sorry. Okay, so if it is 0 here, it will be open. If it is 0 here, it will be open. So what is the voltage at the V out? It is 5 volt only, right?
Yes, sir.
Yeah, because the battery is not going to the ground. It is not shorting the battery. It's basically if you're taking, okay, now we'll take the other case. If this is 1 and this is 1. If this is 1, what is happening here? It is shorting or opening. If this is 1 here, shorting. If this is 1 here, what is happening here? Shorting. Okay. So if it is 1 here and 1 here, 1 and 1 in a NAND gate gives us what? 0. 1 into 1 is 1, but inverse of that is 0. So let's see if we're getting the output as 0. So the battery, the 5 volt battery is entering into this, shorting, so it is going here and getting diverted to ground. So it is what, like you have a battery here which is connected to ground. It is just You're shorting, say you have a battery in your car, your positive and negative is there. You're just taking a wire, connecting one wire at the positive and one wire at the negative. So what is happening? If you do that, what you will get? You will get a big spark. That is first thing. And secondly, it is discharging the battery. You understood, no? Because there's no load. So it is providing a short and your battery will fully become zero. So if you take a multimeter and connect one terminal at the multimeter here, and if there's no other terminal, the other terminal is connected to ground. So if you use one terminal here and one terminal here, you will get basically zero volt because it is a short. Everyone clear with this?
Yes.
So your V output will be what? Zero. So for 0 and 0, your V output will be what? V output will be what? If this is 0 and this is 0, your V output will be what?
1.
0.
How 0? 1 it will be, no? If this is 0 and this is 0, it will be 1. Like confusing me also. Okay? So it will be basically 1. And if it is 1 and 1, then it is a short. That means all the 5 volts is diverted to ground. Then it will be what?
0.
0. Correct. Now if you have 0 and 1, so if say this is 0 and this is 1. So if this is 0, is this basically shorting? No, it is an open circuit only. And if this is 1, this is shorting, right? So current is moving here, but it will not go into this stage only, right? So this is an open circuit. So what is the value? What is the value here? V output? 1, no? Okay, so 1 into so 0 into 1 gives us what? 0. Inverse of that gives us 1. So it is still satisfying the NAND gate. And in the same way, if this is 1 and this is 0, now if this is 1, what is happening here for these two terminals? Shorting or opening? If I'm giving 5 volts here, what is happening to these two terminals? It is shorting. If I'm giving 0 here, what is happening to these two terminals?
Open.
Open. Yes. So now think, battery supply voltage is going here, current is going here, current is entering, ding, 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 entered here. Okay. Now, once it enters here, what is happening here? It is an open circuit. So is current entering into the ground? No, it's not entering into the ground. So if the current is not going towards the ground, then your V output will be what? Is your battery shorting? No. So your V output will be basically 5 volt only, that is 1. So if you have 0 and 1, or 1 and 0, you will get the V output as 1 only. Okay guys, I think it's time up. So the next lecture is so Vishwatej, okay, and Venkatesh, just remind me, okay? This is basically where we stop. Okay. Now for you all, it will be in the next week only. Okay, that I will give you all because you are getting only one lecture. Huh? So remember that it is on the 17th slide here. Okay.
Okay, sir.
Next for you all, you will go for circuits, combinational circuits and sequential circuits. All right. Okay. I'll just take your attendance. You all understood till here? Is it easy?
Yeah, easy.
Okay. This part is easy. Afterwards, the later part is there. Okay, but we will do it. Okay, I theory. Okay, roll number 1.
Present, sir.
Roll number 2. Absent. Roll number 2. He was there? No. Okay. Roll number 3.
Present, sir.
Roll number 5. Roll number 5. Absent. Roll number 6.
Present, sir.
Present, sir.
Okay. Roll number 5. Rohit. Sorry, I didn't see you. Okay. Roll number 7. Shane.
Yes, sir.
Roll number 8.
Present, sir.
Okay. Roll number 9.
Present, sir.
Roll number 10. Okay. Present. Roll number 11.
Present, sir.
Roll number 12.
Present, sir.
Roll number 13.
Present, sir.
Roll number 11 is present.
Present, sir. Hello.
Yes, yes. Okay. Yeah, yeah. Present. So only roll number 2 is absent. All right. Rest all are present. Okay, guys. Have a wonderful day ahead. Okay. If there's any doubts, you can always call me. Okay. Give me a call on my phone, whatever the time. Okay. No issues. And just remind me to send you all. I'll send it to you all on WhatsApp today. Okay, whatever PPTs and all are there. Okay. So have a great day, guys. Thank
Yeah,
you.
thank you, sir.
Sir.
Thank you,
Thank you,
sir.
sir.
Thank you.
Thank you, sir.